What triggered the Big Bang? Alright, I have a question for you. What's in your Spotify playlist? One of my favorite songs was written and played by Dream Theater. This is how it goes. Where do we come from? What brings us here? Where do we go after we pass away? We don't know how to respond to the last two queries, but we do know something about our origins, the Big Bang. Even though the term place in this context is vague, scientists have argued that we all originate from the same location. We should state that we are all products of a single singularity. Your body's stuff is billions of years old, according to the Big Bang Theory, because nothing existed before it and everything else came from it, even us. Yet, what caused the Big Bang? Learn more about the Big Bang Theory and the universe's beginning by watching this video with me. Secondly, it may be erroneous to refer to the Big Bang as a theory. The word theory conjures up images that are rather fantastical in the minds of those who are not accustomed to scientific discourse. This isn't the case though. In the context of science, the word theory does not have the same meaning as it does in the phrase in theory. The word theory in science refers to a set of hypotheses that can coherently explain a lot of observations. The reason theories are taught is because they show the current state of our understanding of a certain set of occurrences. Although they may always be improved, they are now the best option available. It means nothing if you hear someone say, "It's just a theory." The question, "Why do we teach basketball since it's merely a series of movements?" would be analogous. We instruct it specifically because it consists of a series of motions to which we ascribe a physical, social, and cultural significance. Based on astronomical facts and observations, the Big Bang is actually the most widely accepted theory in the scientific community. It is a cosmological model based on the hypothesis that the universe started expanding at a very high pace in the distant past, starting from an extreme curvature, temperature, and density condition, and that this process is still going on now. Most astrophysicists believe that all of the stuff in the universe today, including the matter in people, plants, animals, the planet, stars, and galaxies, was generated at the beginning of time, which is estimated to have occurred roughly 13 billion years ago. Everything in the known universe was crushed into a dot smaller than an atom when the universe first started, according to science, and every last bit of energy was crammed into that tiny of a point. The explosion from this incredibly dense point created stuff and propelled it outward to form the billions of galaxies that make up our huge cosmos. The Big Bang was the name given to this enormous explosion by astronomers. There was no explosion like the Big Bang in the history of the planet. For instance, the air is moving through a hydrogen bomb explosion at around 300 meters per second, with a center temperature of roughly 100 million degrees Celsius. The temperature of the entire universe was estimated to be 1,000 trillion degrees Celsius, just a tiny fraction of a second after the explosion, according to cosmologists, who also believe that the Big Bang flung energy in all directions at the speed of light, 300 million meters per second, a million times faster than the H-bomb. Even the centers of the universe's brightest stars are considerably cooler than that. The Big Bang is therefore the observed reality, although some specifics still need to be figured out. There are many possible outcomes, and we may require several explanations to account for them, or we may not have any explanation at all. In actuality, science is more about being incorrect than it is about always being correct. If every detail was fully understood, science would lose its fundamental value. The Big Bang is special in another significant way as well. The Big Bang did not grow through anything, whereas the detonation of a bomb produced by humans does. This is due to the fact that at the beginning of time, there was no place for expansion. This means that even if I and you would have been burned alive if we had been seated on the singularity at the time, we wouldn't have heard a boom. The key concept is that every explosion has an ignition point and an explosive center. Why not mention the Big Bang? Let's say you step outside while on a date to observe the sky. Suddenly, he or she asks you to identify the location of the Great Bang. In this situation, I would advise leaving right away. There is no place in the sky where you can point and say, that's where the Big Bang was, since there is no center point. Because of the Great Bang, which occurred everywhere and on the moon, sun, your bedroom, and in every other place as well. The universe was also only a minuscule fraction of a second old at the peak epoch. In actuality, it was only 10 to 36 seconds old, or close to that, making it even more minute than a minuscule fraction. From that point forward, we have a pretty good idea of how the universe functions. Of course, there are some unanswered questions, but overall, we have at least a rough idea. Nevertheless, at even earlier times, our comprehension of the universe becomes hazy. The forces, energy, densities, and temperatures rise to an unmanageable level, and the physics knowledge we've pieced together over the ages just can't keep up. The region of quantum gravity, the unsolved great puzzle of contemporary physics, is where gravity starts to get very important at small scales in the very early cosmos. We utterly lack knowledge on strong gravity at small sizes. We simply don't. We simply don't comprehend the nature of the universe before 10 to 36 seconds. We're a little lost before that, but the Big Bang Theory is great at explaining everything following it. Learn this, we are unsure of the meaning of the word before at tiny enough scales. Our nice, ordered, friendly spacetime is transformed into a broken jungle gym of loops, tangles, and rusted spikes at extremely small sizes, and by extremely small scales, I mean smaller than the tiniest object you can possibly fathom. At those scales, concepts of time or space intervals are largely irrelevant. Who is to say what is happening? The only thing we can do is make educated guesses. For instance, in a recent publication that was published in November 2019, researchers outlined the potential causes of the explosion, which is crucial for the theories that scientists use to comprehend the universe's creation. They specifically identified the necessary conditions for a flame to spontaneously accelerate, self-generate turbulence, and transition into explosion. Actually, they were investigating supersonic reactions for propulsion when they discovered this mechanism. In order to create a hypersonic supernova explosion, the unconfined flame must be subjected to the proper amount of turbulence and mixing until it becomes self-perpetuating. At this point, the flame starts to burn the ingested energy. Of course, there are other theories and models that make an effort to explain what started the Big Bang, but for the time being, they are all just conjecture. We can do science if these concepts can offer observable hints. What observations, though, gave rise to the Big Bang Theory? Edwin Hubble found in the 1920s and 1930s that the universe is expanding and that galaxies are separating from one another at a speed determined by an equation known as Hubble's law, V equals h times r. Here, V stands for the galaxy's recessional velocity, R for its distance from Earth, and h for the Hubble constant, a proportionality constant. Although the exact value of the Hubble constant is unknown, it is widely accepted to be somewhere in the range of 70 kilometers per second for every megaparsec of distance. 1 megaparsec is equal to 3 times 106 light years is the formula for a megaparsec. This implies that a galaxy 1 megaparsec from us will be regressing at a pace of around 70 kilometers per second, whilst a galaxy 100 megaparsecs from us will be regressing at a speed of 100 times this. In other words, the Hubble constant controls how quickly the universe is expanding. Since the cosmos is expanding, it makes intuitive sense that everything must have once been crammed into a little space. As we modify Hubble's law, we can see that the Hubble constant, whose inverse has units of time, can be used to calculate the age of the universe in relation to it. We discover that by changing kilometers for megaparsec in the Hubble constant, we obtain a quantity with seconds as units when we invert h, kilometers canceling out in the denominator and numerator. We obtain 3 by 1017 seconds, or roughly 10 billion years, for a Hubble constant of 100 kilometers per second per megaparsec. This is essentially how we get at the universe's age. This essentially sums up our current understanding of the Big Bang concept and its origin. but it is anything from straightforward to attempt to explain the creation of our universe. But we should be grateful for our curiosity, which, when combined with a healthy dose of optimism, can help us better grasp the processes that underpin the creation of the cosmos. We'd like to leave you with a line from the song The Spirit Carries On, which we mentioned in the introduction. I may never find all the answers, I may never understand why, I may never prove what I know to be true, but I know that I still have to try. Here's where the video ends. Thanks for watching. Do you like the Big Bang model? Do you believe we will ever find out what really caused the Big Bang? Please comment below with your thoughts.